In this video, we're going to look at the algorithm used to change a repeating decimal into a fraction. So I'm going to look at my first example, the 0.7 repeating. What I see is that the number is equal to 0.7 repeating. So I'm going to write that phrase using n as to mean the number is equal to 0.7 repeating. And I'm going to do that twice to get this problem set up. Okay, I'm going to change colors to red so that you'll see how I change the top equation. I'm going to look at the decimal. That decimal right now is in front of the 7. I need to move it to the right-hand side of the repeating digit. And then I'm going to recopy the repeating digit. So what I've done is I've moved that repeating symbol right there on over. So that decimal is now 7.7 repeating. Now I cannot just change the right hand side without changing the left hand side. Since I've moved the decimal once, I multiply the n by a power of 10 that has 1 0 because I moved it once. The bottom equation, what I need to do is make sure that the decimal is right in front of or to the left of the repeating digits, and it already is, so there's nothing I have to do on that one. Now what I do is see this as two problems where I'm going to subtract on each side. So the left hand side I have 10n, take away an n, that means I have 9 n's. On the right hand side, what I have going on is, remember it's 7.7 repeating, I'm going to take away 0.7 repeating. Well, these 0.7 repeating take away 0.7 repeating, that's a 0. So I just get a 7. So the purpose of doing that was to get rid of the repeating part of the decimal. Now I've got 9n is equal to just 7. So I solve that equation by dividing by the n. That causes those 9's to cancel out, and I now see n is equal to 7 over 9. So remember what n represented it in the beginning. It represented the number. So it means the number is also equal to 7 over 9. Let's look at the second example. It's a little trickier because I only have one digit that repeats and I have two digits that don't repeat. Let's look at this one. I'm going to start out the same way. I'm going to write down twice that the number is 1.04 repeating. So the number is 1.04 repeating. Now switch colors. Remember, in the first one, I moved that decimal to the right of the repeating symbol, so that means it goes there. This time I see it moved twice, so I multiply by 100, because I need 2 zeros for moving twice. And then, remember, I have to recopy what repeats once, because what I'm doing is moving that repeating digit over. Okay, on the bottom one, the rule is the decimal needs to be to the left, so it does have to move over once because it's got to be right in front of the repeating symbol. So I moved it once, that means I multiply that side by 10, 1 0 for the movement of once. Now I subtract, I've got 100n minus 10n, so that's 90n. On the right hand side, let me rewrite it out so you can see what I'm doing. I've got 104.4 repeating. Take away, it's now 10.4 repeating. So I can see that whenever I do this subtraction, the repeating part is going to go away because that's just 0. So I need to just think, what's 104? Take away 10. Well, that's going to be, show you the math, 94. Now I finished the problem by dividing by the 90. On the left-hand side, the 90's cancel out, meaning the number is equal to 94 over 90, which now I would want to start reducing that, but most of the time, all of your programs like Khan will accept the answer in unreduced form.